So today we're going to be doing question 242, valid anagram. So this question in particular, you're given two arguments, right? S and T, both being equal to strings, and we want to see if it's an anagram. An anagram is two words, whether those words are mixed up or not, as long as both of those words have the same amount of letters, or not the same amount of letters, but the same exact letters, right? Even if they're arranged differently, it's an anagram. So in example 1, you could see you have S, which is equal to anagram, and T, which is equal to nanogram, right? They look different, but if you take a closer look, they have the same amount of words, the exact same letters within them. So I even wrote here how this would look. You have three A's, one N, one G, and one M, right? They contain the same amount of those. So how are we going to see if S and T are equal to one another? Well, what we could do is actually in the code kind of create something similar to this, and the way we do that is we're creating a hash map. So what a hash map does is it stores the value and the amount of times that value has appeared. So if we were to loop through anagram and add these values into the hash map, you could see A appears 3 times. So you have A, which is our key, and then you have our value, which is 3, right? Hash maps are also known as dictionaries because a dictionary has a word and it has a definition, right? The word being the key and the definition being the value. This is the exact same way of thinking, right? A is our key, and the value, the amount of times it happens, is 3. So what we're going to do is we're going to create two hash maps, right? One for S and one for T, and just return if that hash map 1 is equal to hash map 2. Because with hash maps, you're able to do that. You're able to see, okay, is this equal to this? And if they are equal, then they'll have the same amount of values, right? A will be equal to 3, N will be equal to 1, G will be equal to 1, and M would be equal to 1 for S and T. And because of that, it would return true. So the first thing we're going to do is create our hash maps, right? So you're going to have hash map 1 equals this, and hash map 2 equals this. So these are now two empty hash maps. And now we're going to loop through S and T and add to those hash maps. So let's loop through S first, right? So for X and S, right, you're going to check if X is in hash map 1, which in this instance, there's not because we're in the first loop, but let's say if it was, then hash map at index S plus or equals 1, right? Else, hash map at index X equals 1. So what's going on here is, let's say we're in a first loop for anagram, right? For X and S, right? Let's say S equals anagram. So is A in hash map 1? It's not. So you're going to do hash map X, A equals 1, 1, right? So for the first loop, this is what A would be equal to. Then we go to the next one, right? You check N for X, X is N. Is N in hash map 1? It's not, right? So you're going to do N equals 1, right? So N equals 1, right? And then you now go to the third loop. For X and S, X is A again. Is A in hash map 1? It is. So you do hash map A plus or equal 1. So this is 2 now, right? So because of that, hash map 1 should be fully set, and we do another for loop. But for this case, we're going to do it for T. So for X and T, right, you're going to do if X is in hash map 2, right, hash map 2 at index X plus or equals 1, we're literally doing the same thing, right? Else hash map 2 at index X equals 1, right? So now at this point, hash map 1 and 2 are completely filled. All we need to do is return hash map 1 equals hash map 2. And if we run this, if they're not equal to another, it's going to return false. If they are equal to another, it should equal true. Let's see. Okay. Yeah. Hash map 1 and 1. There you go. Perfect. Awesome. So you see all we have to do is create hash maps, create two for loops, one for s and one for t, and just return if hash map 1 is equal to hash map 2.